Cartography is the art and science of understanding our world through maps. It combines measurement, design, and technology to represent the Earth's surface accurately. Through cartography, we organize geographic knowledge in a structured way. This field has transformed through scientific discoveries and technological innovation. From hand-drawn maps to digital systems, cartography reflects efforts to represent the world. The journey of cartography is divided into distinct stages, each defined by unique tools. In ancient times, people drew maps to record land, resources, and understand territories. Later, maps became more precise, fueling exploration and a better understanding. The modern period gave birth to geographic information systems, revolutionizing data. Today, mapping is interactive, dynamic, and powered by the capabilities of AI. Modern maps are intelligent platforms that guide decision-making processes across fields. This revolution shows how far we've come, connecting people and places across the globe.
Mapping's story began long before science. Cave paintings in France and Spain revealed spatial awareness, the first step toward cartography. In Egypt, papyrus maps guided land division. In Mesopotamia, the Babylonian world map was among the earliest maps. By 500 BC, Chinese maps recorded kingdoms on silk. Later, Ptolemy introduced latitude and longitude. These maps marked humanity's first attempt to understand the world. Welcome to an exploration of cartography's transformation, delving into the modern mechanical and printing age from the 15th to the 18th century. Long ago, maps were meticulously drawn by hand, each a unique work of art. Yet this process was incredibly slow and often prone to inaccuracies. Then, a revolutionary shift occurred in the 1440s with Johannes Gutenberg's groundbreaking invention of the printing press. For the very first time, maps could be produced rapidly and disseminated widely, reaching a much broader audience across different regions. A significant early example was Cardinal Nicholas Germanus's Map of the World from 1477, marking a true milestone in the evolution of mapmaking. Soon thereafter, the innovation of copper engraving emerged, enabling mapmakers to incorporate incredibly fine details, such as rivers, mountains, and cityscapes. Renowned figures like Gerardus Mercator and Abraham Ortelius became pioneers, crafting influential maps and comprehensive atlases that guided explorers across vast oceans and uncharted territories. By the 18th century, the introduction of new, advanced tools and techniques elevated mapmaking to unprecedented levels of precision, transforming it from an artistic endeavor into a rigorous scientific discipline.
In the 19th century, new instruments and surveying methods made mapmaking more accurate than ever before. National mapping systems, like Britain's Ordnance Survey, set global standards for precision in cartography. Then came photogrammetry, a revolutionary technique that transformed how maps were created. By capturing landscapes from the air, cartographers could create detailed maps faster and with greater accuracy. During World War I and II, aerial images proved crucial, helping to map battlefields and, later, entire countries. In 1972, NASA launched Landsat-1, the first satellite designed to continuously image Earth's surface. This groundbreaking satellite provided invaluable data for resource management, environmental monitoring, and mapping. By the 1980s, computers brought maps into the digital age, revolutionizing cartographic practices. Cartographers could now layer data on population, terrain, and land use by creating geographic information systems.
In the 21st century, cartography has become a digital and intelligent science. Geographic Information Systems, or GIS, first developed in the 1960s, allowed the integration of spatial and statistical data on one platform. With satellites and GPS, maps became accurate, dynamic, and globally accessible. Today, AL drives the next stage of digital mapping. It analyzes satellite images, detects new roads and buildings, and creates real-time maps that show traffic, weather, and environmental change. In smart cities, AL and sensors collect continuous data to improve transport, energy, and urban planning. Emerging 3D mapping technologies now build realistic models of the Earth. The vision of a digital Earth connects AL, GIS, and real-time data into a living, three-dimensional representation of our planet. The future of mapping is intelligent, spatially aware, and vital for understanding and protecting the world we live in.